Okay, it's 5:27. This is video number 106, and the title here is a soup can and algebraic expressions. So we're very familiar with the soup can. I'll give you one as an assignment to do on your own, trying to make the algebraic expressions interesting so they combine nicely. And I'll start with the problem and what they ask you. Typical of the Regents, by the way. Here's a soup can where the radius is some number minus 1. Obviously, it can't be 1, so we'd say it's greater than 1. We'll leave restrictions alone for now. And then the height is some number plus 1. Okay? So we eliminate negative numbers, we eliminate 1, and we have this sort of idea of what we're doing. So number 1, they want us to find the surface area. So we're just treating these algebraic expressions like numbers, like we do in polynomial math. And I'm going to find the surface area. I wrote all the easy stuff out, and I'll go over it. And then I'm going to find the volume, which I'll work out on the whiteboard with you. So we'll move this over now. I also notice one more thing before I move to the right over here. They often use the word simplify. Simplify means combine like terms and factor. So we'll see that word a lot. So it's now has like two meanings, simplify. Like a fraction when it was simplified 2 over 4, simplify equals 1 over half. Now with these algebraic expressions, we're saying simplify means to combine like terms and factor, which is what I'm going to do over here. They're very fond of the soup cans because it lends itself nicely with the idea of factoring. So I just explained how I set this up. There's the label of the can over here, which is represented by 2 pi r h. You're familiar with that from your last test. And notice that there's a top and a bottom of the can. So we represent that 2 times the top and the bottom, which is just a circle, and so it is there below 2 pi r squared. Okay? So this is the top and the bottom here, and this is the label part. That covers all the surface area. So now we get a chance to use our perfect square work and the things that we learned from before. If the radius and the height are what they are, so there's your radius, there's your height, and there's your radius all over again. But we don't have to do FOIL. We don't have to knock ourselves out. We know that the minus, the plus, gives us this configuration, okay? So it's x squared minus 1, everything times 2 pi. And when we do the same math over here, we're very familiar with x minus 1 squared configuration, and we just write it out, a squared minus 2ab plus b squared, as described by you. And now I have to put like terms together, because these are in factored form, but I need to put everything together and then factor it. So when I do that, I'm just distributing here. I get all these terms. You can check me if you like, and all I have to do now is combine like terms and then factor. So I'm going to lower this just a little bit more, and let's go and do this. So here we are. The 2 pi and the negative 2 pi are going to cancel, and 2 pi x squared plus 2 pi x squared is 4 pi x squared. So that takes care of those 2 terms. And what's left? Minus 4 pi x. Now, this is not the answer anymore for us. It has to be simplified. That means it has to be factored if it's factorable. So we look at it and we realize, oh, there's a pi here, excuse me. That's very important. And we realize that we can take out things that match. And what matches here? 4 pi matches. What else matches? X. What's left over? X minus 1. And there's the correct answer. So that's the work we got from the math that we previously know. This is going to be the work we come up with when we're using factoring. So again, I'll just put it over in the corner over here. I just don't want to assume that you can do these things when you can't. So I'm just writing 4 pi x squared. That's the first term here. And there's the negative 4 pi x. And I'm writing out their factorization, and I'm matching. And you can see what I'm matching here. There's the 4 pi x. I put it on the outside. There's what I couldn't match in the first term. And there's that negative 1 that I told you there that's left over, even though I matched the 4's together. And so you go backwards and you come up with this, and this is properly done. You'd be expected to do that in Regents Math. And they ask it quite a bit. I'll give you another problem that they came up with. And now I go on to B, and I'm going to do the same thing and see what happens when I try to do the volume. So I'll quickly erase the math that I wrote here. And now we're going to use our new math and do the cubes. Okay, so volume means cubic. You're required to know that if you want to take the Regents and move on in math or finish off your math for high school. So make sure you're paying attention to me. So then we go, what is volume? Well, volume is pi r squared v. So that means that the volume here is pi r squared, which is x minus 1 squared. And that, not the v, h here, sorry. Tiny mistakes. Not going to affect anything. And that's x plus 1. So instead of knocking myself out, multiplying all this stuff, I'm just going to use a little trick that people have always been using. I'm going to rewrite this. After all, doesn't x minus 1 squared equal this by definition? And then I rewrite that, so this just became that. And that makes life a lot easier for me, because now I can multiply this times this, and I get to make my multiplication easier. And there we go. And so I just did this trick, and you learned it, and you're responsible for it. It comes up all the time in math, okay? Especially in the Regents Math. They really like this. And we're asked to simplify now, so don't forget that. And now I do have to FOIL, so I will do that. And I'll leave the pi on the outside. And I'm going to get x cubed, you should know how to do that now, minus x squared plus 1, okay? And you can double check me there to make sure that we got all that down, okay? And now we'll make it equal again, and we'll put it into standard form. And there's minus x squared minus x plus 1. By the way, in more advanced math, you'll see this formula for a cube squared. It does have meaning, but we're going to leave it alone for now. And now, can I factor this? If I multiply everything by pi, I'm just going to have to take the pi out again. Is there anything I can do here? Well, the answer is this is not factorable. This expression inside the parentheses is not factorable in the math that we can do. Everybody is co-prime. All the terms are different. This is completely factored. So the simplification of that is this. And multiplying everybody by pi desimplifies it, to use that word. So there we go. I'm going to probably give you an assignment on that tomorrow to do something like this. And we're just putting together the math that we did before, where they want you to be able to put everything together. And now that we know how to factor, here's perfect examples of how to do that. So I'll let you try one of these, and I'll do it later. But right now, this is what we plan to do for you for today. So tomorrow, we work on the assignments that I know a whole bunch of kids are working on right now as we speak. And we'll put one of these in tomorrow, and we can finish up the book, some of the problems in the book. And I do have another word problem for you.